Okay, good morning. Today we'll be taking investment appraisal. The question actually specified that we are going to cover both net present value, payback period, and making decision for the firm on which investment to choose. I'll read through the question. Ican November 2015, question 1 on investment appraisal. The board of directors of Danda Company Limited is proposing the purchase of either of two machines that have been proved adequate for the production of an engineering product G. The two machines are Sigma 5000 and Delphi 7000. Production in the first year would be affected by installation challenges and inadequate understanding of the operating instructions of the machines. Information available from the production profile of the two machines are shown below. We have Sigma 5000. Here we have production capacity year 1 to 6. Production capacity in percentage 60, 90, 100, 150, and 30%. The cost of machine is 16,500,000, while the lifespan is 6 years. Therefore, 7,000 production capacity in percentage equally given. The year 1 to 6 percentage will have 50, 100, 100, 100, 80, then 50. The cost of the plant is 18,300,000, while the lifespan is 6 years. Other information relevant to the company operations and administrations are: the selling price per unit is 300 naira, variable cost per unit is 150, annual fixed overhead exclusive of depreciation is 1,200,000. The company depreciation policy is straight line basis. The budgeted production capacity is 100,000 units. No opening or closing inventory is envisaged. Then all sales are for cash. All costs are equally for cash. Required: prepare the 6-year profitability statement for the two machines. Prepare the 6-year cash flow statement for the two machines. What is the payback period for the two machines? Determine the net present value for the two machines. Then determine the net present value of the two machines if the acceptable discount rate for the company is 15%. Then finally, which of the two machines should the company acquire? So this is the question, and we will be taking the solution shortly.
I have.
Okay, we'll take the solution to the question we have just read. According to the question, they are considering two projects, Sigma 5000 and Delphi 7000. So we are going to consider the two based on the information you have been given here. The requirement is that we'll prepare the 6-year profitability statement for the two machines. So we'll have Sigma, that is from Ican, November 2015, expression 1. So Sigma 5000. There are some profitability statement for the 6 years. Before we take that, we'll do some workings. To get quantities. They didn't give us any quantity. They actually told us their projected capacity is 100,000 units per year. But they gave us probabilities we can use in getting the quantities. So the working to be the workings 1 will be to get the quantity. So quantity for Sigma 5000. Quantity for Sigma, the probabilities given are, so we have the 1, 2, 3, 4, 5, and 6. The probabilities given are 60, 90, 100, 150, 50 and 30%. So multiply the 100,000 which is projected by the probability. So getting the quantity quantity will be 100,000 projected each of the year times the probability provided in the equation. We'll have 100,000 in 1 to 6 times each of the probabilities provided. And the probabilities provided will have 60%, we'll have 90%, we'll have 100%, we'll have 100%, we'll have 50% and 30%. So to get each of these, 100% clearly means they will have the whole of the projected quantity for this year, 100,000 units. Here is half of it, is 50,000 units. Here I think 30,000 units. Here is 90,000 units. Then we'll have 60,000 units. So that gives us the quantity. In order to get our profit, the net profit, I'll start by year 1, 2, 3, 4, 5, 6. I'll be needing the revenue. Less the variable cost. We locally have fixed costs as provided and depreciation, and finally net profit. But each of these are not given. We have our quantities here. We have to solve to get our revenue. So the price provided here, they say the selling price per unit is 300. So I think I'll do the workings somewhere. 2 workings, 2. Workings 2, I have revenue. For revenue, we'll have year 1, year 2, year 3, year 4, year 5, year 6. So the revenue will be each of the quantities provided: 60,000, 90,000, 100,000, 100,000, 50,000, and 30,000 multiplied by the sales price per unit, which is 300. Sales price per unit 300 each. So this will give us the revenue for each year. I'll do the computations. So I have this 60,000 times 300, giving us 18 million. We have 90,000 times 300, giving us 27 million. We equally have 100,000 times 300, which gives us 30 million. This is equally 30 million. Then here, half of it, 15 million. Then lastly, we have 30,000 units times 300. It gives us 9 million. So this gives us the revenue. We can decide to reduce the actual volume of the value involved. So I'll be having 18 because of this, 27, 30, 30, 15 and 9 million. So less our variable costs. Our variable cost will equally get the same way. They gave us our variable cost per unit. As provided in the equation, variable cost per unit is 150 naira. So that will be working 3 variable cost. Half of this amount. Year 1, year 2, year 3, year 4, year 5, year 6. There are 60,000 units, 90,000 units, 100,000 units, 100,000 units, 50,000 units, and 30,000 units as derived, multiplied by the individual variable cost per unit is 150. Variable cost per unit being 150 is half of this. We are going to be having 60,000 times 150, giving us 9 million. Half of 27 million. That should give us 13,500,000. We have 15 million. 15 million. We have 7.5 million and 4.5 million. Each variable cost captured, so we'll have them as 9 million. 9 million. We'll have 13, 5. We'll have 15. We'll have 15. 7.5 and 4.5. The fixed cost as provided in the equation. Our fixed cost provided in the equation, I said, is 1,200,000. So each of the year, we are having 1,200,000 each year as fixed cost. So the depreciation is not provided, I will have to work to get it. They say they are using straight line method depreciation. The cost of the machine for Sigma is 16,500,000. So I'll divide that by 6. So depreciation is 16,500,000 divided by 6. That should be for Sigma 5,000. To get the value. 16,500,000 divided by 6 should give us 2,750,000. So each year depreciation will be having 2,750,000. So here the less 2,750. So 750. 2,750. So we can get our net profit, then we'll conclude the profitability statement for Sigma 5,000. So we'll have 18 minus 9 minus 1, 2 minus 2,750 gives us 5, 50, 50, is still the same. So 5,050,000. For year 2, we have 27 minus 13,5 minus 12 minus 2,750 equal to 9,550. For year 3, we're having 30,000 minus 15,000 minus 12 minus 2,750, giving us 11,50. Year 4, 30,000 minus 15 minus 12 minus 2,750, giving us 11,50 also. Then year 5, 15,000 minus 7,5 minus 12 minus 2,750, giving us 3,550. 3,550. Year 6, 9,000 minus 4,5 minus 12 minus 2,750, giving us 5,50. So that concludes the profitability statement for Sigma. So I'll take the same steps for profitability statements of Delphi or Delpha, whatever name it is. So we'll take for Delpha, I will need to wipe these workings. Your post-its. Okay, so we'll take profitability statements for statements for 6 years. That will be for Delphi, Delpha 7,000. Says you are taking for Sigma 5,000 in order to complete the A requirements of the question. Still the same steps, we'll be getting the A, revenue, variable cost. A, 1, 2, 3, 4, 5, 6. Revenue. Well, variable cost. We probably have fixed cost, depreciation, and net profits. Fixed costs, depreciation, net profits. So we are going to proceed with the workings for each of them, just as we did for the previous computation. We'll have the workings for revenue. This is workings 1. Revenue. As provided in the question, there are percentages provided, and we will need quantities. You have not gotten the quantities. The percentages provided, let me get the quantities first. So let me call this is the workings 2. Workings 1, let me get the quantities. So year 1, year 1, 2, 3, 4, 5, 6. The quantities, I'll multiply 100,000 times each of the percentage. 100,000, 100,000, 100,000, 100,000, 100,000 times each of the percentage provided for Delta. So the percentage here I have is 50%. I have 100% of delta. Equally around 100% again. 100%. 80%, and lastly 50%. All of this for delta. So if I should multiply this, I'll be having 50,000 units, 100,000 units, 100,000 units, 100,000 units, 80,000 units, 50,000 units. So revenue units times the sales price per unit, which is still 300. So I'll be having 50,000, 1, 2, 3, 4, 5, 6, 50,000 times 300, 100,000 times 300, 100,000 times 300, another 100,000 times 300. Well, we have 80,000 times 300, then 50,000 times 300. That should give us the revenue for each year for Delphi. So I'll get that 50,000 times 300, giving us 50 million. This should give us 30 million. 30 million. 30 million. Here we have 15 million. Then lastly we have 80,000. 80,000 times 300, giving us 24 million. 24 million. So that gives us revenue. Still reusing the values. I have 50 million. I have 30. I have 30 million. 24, and 15. So each of these less variable cost. Variable cost have not been provided. I say variable cost per unit is 150, so I can still do my variable cost here. That is 1 3. Variable cost. Now for variable cost, year 1, year 2, year 3, year 4, year 5, year 6. I'll multiply each of the units times the variable cost per unit. So still 50,000 times 150, which will be half of this amount, which is 7,500,000. I have 100,000 times 150, should give us 15 million. 100,000 times 150 equals 15 million. 100,000 times 150 equally giving us 15 million. Then I have 80,000 times 150 should give us 12 million half of this. Then 50 million. 50,000 times 150 this makes up our variable costs to around 7,500,000, 15 million, 15 million, 15 million, 12 million, and 7,500,000. This cost is provided to be the same as this. So around 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Then the depreciation, based on their cost of machine, their cost of machine is 18,300,000. So you get the depreciation of 18,300,000 divided by the useful life of the machine, which is 6. So 18,300,000 divided by 6. 18,300,000 divided by 6 should give us 3,050,000 naira as the depreciation for each year. So here gives us 3,050, 3,050, 3,050, 3,050, 3,050, 3,050. Now we can get the net profit to complete the A requirement for profitability statement for both machines. To get the net profit from year 1, we are having 15 minus 7,500 minus 1, 2 minus 30, 50 is 3,250. 3,250. Year 2, I have 30 minus 15 minus 1, 2 minus 3,050, 10,750. Then year 3, I'm having 30,000 minus 15,000 minus 1, 2 minus 30, 50. Keep these ones are the same. So 10, 750. Here is 10, 750. Then we'll work out for the remaining 2. 24,000 minus 12,000 minus 1, 2 minus 30, 50. Giving us 7,750. 7,750. And lastly, for year 6, 15,000 minus 7,500 minus 1, 2 minus 30, 50. 3,250. 3,250. So we are done with the profitability statement for both machines. We'll go to the D requirement, which says prepare the 6-year cash flow statement for the 2 machines involved. So cash flow statement I need to work out here.
Okay.
All right. So the D says cash flow statement. Cash flow statement. So I am going to do for sigma 5,000 for delta 7,000. So the cash flow I'll be adding up the net profit plus depreciation, net profit plus depreciation. So that will be year 1, year 2, year 3, year 4, year 5, year 6. Same year 1, year 2, year 3, year the net profit for Sigma, we have 50-50. We have 9-5-50, 11-0-50, 11-0-50, 3-5-50, 5-50. Each of the year's depreciation is still the same: 2-7-50, 2-7-50, 2-7-50, 2-7-50, 2-7-50, 2-7-50. To get each of the year's cash flow. So to get the cash flows, we have 50-50 plus 2-7-50, giving us 7-8. What I have 9-5-50, 9-5-50 plus 2-7-50, giving us 12-3. These are the cash flows. 11-0-50 plus 2-7-50, giving us 13-8. 13-8 equaling 13-8. And the last 2 years, we have 3-5-50 plus 2-7-50. 3-5-50 plus 2-7-50, giving us 6-3. And lastly, 5-50 plus 2-7-50, giving us 3-3. So these are the cash flows. For Delpha, we have our net profit of 3-2-50, 10-7-50, 10-7-50, 10-7-50, 7-7-50, 3-2-50. We'll add up the depreciation. We say it's 30-50, 30-50, 30-50, 30-50, 30-50, 30-50. Okay. You want cash flow 3-2-50, 3-2-50 plus 30-50, giving us 6-3. 6,003. A2, we have 10-7-50 plus 30-50, 13-8. So I'll repeat all through: 13-8, 13-8. 13-8, I'll work for the last 2 years. 7-7-50 plus 30-50, giving us 10-8. Then lastly, 3-2-50 plus 30-50, giving us 6-3. So these are the cash flows, and that answers the B part of the equation. The C part of the equation says we should compute the payback period for both projects. What is the payback period for the 2 machines? So I am still going to do it this way. I have Sigma 5,000, and I have Delta 7,000. So the payback, I'll bring in the cash flows. The cash flows are cumulative cash flows. So I have E 0-1, depending on how many years you have cash flows. Cumulative cash flow. So I still have this. The investment would cost They say for alpha, for sigma, 16,500,000. So in bracket, 16,500, the cumulative will still be 16,500. The one cash flow based on what you have there is 7,800. So the cumulative will reduce. So we have 16,500. 16,500. So we're adding a negative number to a positive, which reduces the negative. 16,500 and 7,800. It reduces the negative to 87. 87. So after year 1, now we recovered 7,800, reducing the amount spent to 87. So year 2 cash flow is 12,300, which is way above the 87 being sought for. So we are applying a different formula. Payback period is equal to year before full payment and balance at year of full payment all over cash flow at year of full payment times 12. So this will give us the exact time it will take. So the payback period will be year before full payment as of the first year, because the full payment will be gotten in the second year. So year before full payment, we will have 1 year, and the balance I'm looking for is 87, and the cash flow in that year that will recover will be 12,300 times 12. So that will be 1 year, and we'll get the remaining months. So that will be 87 divided by 12,300 times 12. So 8 months. So 1 year and 8 months. That is what it will take for sigma to recover. So therefore, do the same thing for delta. We'll have year, we'll have cash flows, then we'll have cumulative cash flow. Year 0, the amount spent in the project, they say is 18,300,000. So I'm still using these values. So now 18,300,000. Cumulative is still 18,300. Year 1 cash flow is 6,300. So it reduces the cumulative, they recover this amount in the first year. This negative plus this will reduce the negative. So I have 18,300 minus 6,300. So I have a negative of 12. The next cash flow is 13,800, is year 2. 13,800, which is obviously higher than this. So we'll still apply the same formula. I wouldn't need to write it out. So I have payback period. A year before recovery is the first year. So 1 year, and the cash flow that is being sought for in the year of recovery is 12 divided by the actual cash flow in the year of recovery times 12. So payback period will give us 1 year and 1 year and so 12,000 times 12,000 divided by 13,800 times 12 will give us 10. So 10 months, 1 year and 10 months. So So payback period has been settled. The D that says determine the net present value of the two machines if the acceptable discount rate for the company is 15%. So we'll profile the solution for that. So the D part says you should determine the net present value, NPV. So NPV for both projects. We'll start with the Sigma 5000. So I have the A, I have cash flow, I have discount factor at 15%, since I say 15%, we have the present value. So here I have 0, 1, 2, 3, 4, 5, 6. The cash flows for Sigma, I have initial outlay first of all, say 16,500,000. Just put it this way, 16,500 in brackets. Year 1 cash flow is 7.8. Year 2 is 12.3. Year 3 is 13.8. Year 4, 6.3. Year 13.8 as well. We'll have 6.3 and 3.3. So the discount factor will just use a shorter format to get that. That will be 1 plus 0.15 giving us 1.15 divided by 1.15, giving us the first value, which gives us 1 equal to 0.86 870 approximately, since I'm using 3 decimal, equal to 0.756 equal to 0.658 equal to 0.7 0.572 equal to 0.497 equal to 0.432. So we'll get the present values and proceed to the net present value. Here still gives us negative 16.5. So 78 times 0.870. What did I press? 78 times 0.870, giving us 6786. Year 2, the 12.3 times 0.756. That should be 9298. 9298 points. Yeah, approximately 9299. 9299. We have 13.8 times 0.658. 9080. Approximately 13.8 times 0.572, giving us 7894. Approximately 7894. 63 times 0.497. 3131 approximately. And lastly, 33 33 times 0.432. 1425. 1426 approximately. So the net present value for sigma will now be negative 16,500 plus 6,786 plus 9,299 plus 9,080 plus 7,894 plus 3,131 plus 1,426, giving us 21,116. This is an approximation. This is the net present value. In full value, NPV, in full value, considering we have reduced some values with this, will now be 21,116,000. The net present value for sigma 5,000. We'll do the same for delta 7,000. For delta 7,000, I have here 0, 1, 2, 3, 4, 5, 6. We'll have cash flow. We'll have discount factor. Still at 16%. 15%, sorry. Then present value. So I'll still repeat the discount factor, but the initial outlay or the amount spent for the machine is 18,300. 18,300. Year 1 cash flow 63. Year 2 cash flow 18, okay, 13.8. Year 3 cash flow 13.8, only 13.8. 13.8. And lastly, okay, 10.8, 36.3. 10.863. The discount factor, this is multiplication. Discount factor remains 0.870, 0.756, 0.5, 0.658, 0.572, 0.497, and 0.432. So that will give us our present value here being 18.3. Get the rest of the year. 63 times 0.870, giving us 5481. 5481. Equally have 13.8 times 0.756. 10,432. Approximately 10,433. 13.8 times 0.658, 90.84, approximately 90.80, and 13.8, the last 13.8, 13.8 is 0.572. 7894, possibly. 7894. 10.8 times 0.497. 5368. And lastly, 63 63 times 0.432. 2722. Approximately, giving us net present value equal to addition of all discounted cash flows less the initial outlay. I'll do it like the first one. Negative 18 plus 5481 plus 10433 plus 9080 plus 7894 plus 5368 plus 2722. 22678. 22678. In full value, we have 22,678,000 net present value. So we've answered the D part of the question, which says determine the net present value of the two machines if the acceptable discount rate for the company is 15%. E says which of the two machines should the company acquire. Now, if you are looking at their payback period, the payback period, the company would have acquired Sigma 5000 going by the payback period, which is quicker. This is 1 year and 8 months. Delta is just 1 year and 10 months, which is slightly late compared to Sigma. But if I am going by the net present value, which I believe the company should be looking at, because it enhances the value of the firm. The net present value here of the considering Delta, because it has a higher net present value of 22,678,000 compared to Sigma 21,116,000. And that brings us to the end of this particular session. Thank you very much for your time, and please remember to subscribe to the channel. Thank you.